Okay, welcome back to data structure in the algorithm class. Next to topic formal notation. We already discussed the previous class. So what are the informal notation present in the data structure in the algorithm? Today we're going to discuss formal notation. Okay, the formal notation, three types of formal notation is there. One is called the big O notation, omega notation, and the theta notation. Okay, first we're going to see the big O notation. Okay, the big O notation. So T of n. T of n is nothing but T is the time, n is number of input. So T of n is said to be in big O G of n. G of n is nothing but a small function. So small function carried out the given input n. So T of n is said to be in big O G of n is denoted if T of n is bounded above by the same positive constants multiple of G of n for all large n. N is the number of input. So here the condition n is a large, okay, it's a large value, it's not a negative value, it's only for positive value. So it's a positive constant. So T of n is said to be in big O G of n denoted if T of n is bounded above by same positive constants multiple of G of n for all large n. So given T of n belongs to G of n. T of n belongs to G of n. Okay, because the T of n is the time of process or proceed the number of n. This belongs to depends upon the small function G of n. So T of n is less than or equal to C G of n. C is a constant, multiplicative constant. C G of n for all n greater than or equal to n naught. N greater than or equal to n naught. So here C equal to what is that? C is a multiplicative constant. N naught is non-negative integer. N naught is a non-negative integer. That is going to be positive. So here the representation is the graph. So x-axis is the G of n. So y-axis is the G of n. Okay. So here you mentioned that the T of n is smaller or same order of G of n. So the T of n is below the T of n. So the T of n is below or less than or equal to C of G of n. Okay. So before that n naught is a non-negative integer. So before that is a negative integer. So don't bother about the negative integers, only consider for positive integer. Okay. Right. Example, here you mentioned that 100n plus 5 belongs to big order of n squared. Okay. So 100n. So n squared number of time is multiplicative is n is only multiple by n, then only you reach the n squared. So this belongs to less than. So it belongs to less than. So here mentioned that 5. Okay, suppose n value is 5, or the n value is 1 at the time, this everything is less than or equal to G of n. So T of n is less than or equal to G of n. So this condition is satisfied. Second, big omega notation. So here T of n is said to be in omega G of n denoted D of n belongs to omega G of n if T of n bounded below by the same constant order of G of n for all large n. Okay. So here you mentioned that there is not a below, it's a above. Okay, the correction is above by the same constant order of G of n for all large n. Okay, so here you mentioned that G of n is there. So here we give the T of n. So T of n is larger than the C of n. Either greater than or equal to G of n. Okay. So here we mentioned that n squared is greater than or equal to n squared for r, n greater than or equal to 0. Okay. So n squared is always is less than of n cube. So n cube is greater than is n squared. Okay, fine. Next theta notation. So T of n is to be in theta G of n denoted T of n responds to theta of G of n. Okay. So here T of n is bounded both above and below. So first one is big O T of n is below the order of 4. Theta of T of n is above the order of 4. Here, sorry, omega of T of n is above the order of 4. Here, theta is below or above. So T of n is bounded both above and below by the same positive constant multiplicity of G of n for r large n. Okay. Here we are using the two constants. One is for above C1 is G of n, then another is for C2 is below the G of n. Okay, the intermediate we have the T of n. So here formula is C2 G of n is less than or equal to T of n, less than or equal to C1 G of n for all n greater than or equal to n naught. Okay, so this is the formal notation. So this is one of the important question for data structures algorithm. Compulsory maximum 5 marks in the question for the chances. Okay, so go through the big omega and the theta. Right. Next is basic efficiency cases. Basic efficiency cases. So differ multiplicative constant. Many classes are raised. So here n is different order of 4. A is the base. So n is a different a of n, a power of n. So n is a different order of 4. So n may be 1, 2, 3, just like that. So a is a different base. Base is a binary or a decimal. Okay, binary na 2, decimal na 10. Octa, other hexa octa, so it's 8 and 16. So this is a octa and the hexa. Binary na 2 of n, decimal of 10 of n. The same time, octa na 8 power n and the hexa na 16 power. So n is a different order of growth. Okay, so here the class and the names. One is a constant. Log n is algorithmic. N is a linear. N is a linear. So here n log n is a linear plus logarithmic. N squared is quadratic. N cubed is cubical equation. 2 power n exponential. N factorial. Factorial. Okay, you find out the factorial. First of it, that is the factorial algorithm. Okay, so this is different cases, different asymptotic classes is formally followed. Okay, next the mathematical analysis of non-recursive algorithm. What is the non-recursive algorithm? So non-recursive algorithm is nothing but a sequential algorithm. So recursive algorithm, the algorithm called itself is called recursive algorithm. Non-recursive algorithm is nothing but a sequential algorithm is another name is called non-recursive algorithm. So systematically apply the general framework analysis, the non-recursive algorithm. How to apply the general framework? So suppose we take any one of the example, any one of the algorithm. Based upon the algorithm, we find out that analysis, you probe the analysis, and you generate the general form, the general framework for analysis with non-recursive algorithm. Okay, right. Here you take the example. Find the largest element in a list of n numbers, list implemented an array. Okay. So இப்போ என்ன பண்றோம் அப்படின்னா ஒரு n set of numbers நம்ம input கொடுத்து அந்த inputல எந்த number வந்து maximum அப்படிங்கறத நம்ம find out பண்ண போறோம். So that is mean by you finding the largest element in the present array. Okay. Here you like the pseudo code. So algorithm name is called the maximum element. So you call the two parameters. One array. Okay, so sorry, only one parameter is array. So array is starting from 0 to n minus 1. Okay, right. We first assign the first value of array is the maximum value. So this means that the first value is present to a of 0. So a of 0 is assigned the maximum value. Okay, right. Next, for I is a incremented I is 1 by 1. So using the for loop. So for I starting from 1 to n minus 1. Why is starting the I equal to 1? Because a of I equal to 0 is already assigned the maximum value. So we take the next element is compared to the previous one. So here the next element is the 1. So the position is 1. Previous element position is 0. So a of 0 is compared with a of 1. Okay. So if a of I is nothing but a of 1. The a of 1 value is compared with a of 0 value. The 0 value is already assigned the maximum value. So that is mean by a of I is the next value is greater than the previous value. And so automatically the next value and the max value cannot. So that is mean max value is assigned a of I. Okay. So here a of I is a 1. Previous a of 0 equal a of I because whenever the condition is satisfied at the time, the ith position value is assigned the maximum value. Okay. The for loop is repeated until n minus 1 time. Okay. Finally, we're getting the answer. That the answer value is to the max value. Finally, the max value is written to the main function. So return main function. So finally, the max value hold the maximum element in the given array. Okay, right. So more time execute the for loop depends on the n size. N is nothing but the input size. So input size is carefully watch that. Okay, because the input size is very long. The algorithm is repeated many number of times. Okay, so at the time of confine the input or define the input size is very, very important to produce the quick and the better result of the given algorithm. Okay, right. Next, loop body contains two statements because here the loop body, if two statement, one is called the comparison statement, another is called assignment statement. So these two statement is only repeated at the time of for is execute. Okay, so these two statement is called the basic operation of the algorithm because the two statements only repeated more and more. Okay, right. So here we make that impression a of I is a max value, better than max value. So all time is executed. Okay. So in the the A of I is checking condition. A of I is all time this statement is executed. Okay, starting from n I equal to 1 to n minus 1 time. But the max value equal to A of I. A of I is assigned to max value. The second statement is executed when the first comparison statement is true. Okay, suppose the first statement, comparison statement is not true, the second statement will not execute because no need. So only the second statement executed whenever the first statement condition is true. Okay, so the comparison A of J max value. So it's the first statement that is all time is executed. Second, the assignment, assignment. So max value equal to A of 5 that is not executed for all time. Whenever the first comparison statement is true, then only the second statement is executed. Okay. So you are playing for this values the given formula C of n is number of time the comparison executed. So here C of n is the comparison of n equal to is summation of I equal to 1 to n minus 1 time is 1. The value is 1. Here the 1 repeated n minus 1 time. So the function is maximum time is repeated is n minus 1. So C of n, the summation of I equal to 1 n minus 1 equal to n minus 1 times the answer is n minus 1. The n minus 1 belongs to what is that? Theta of n. Okay, theta of n belongs to theta. So n because n is the maximum value. So is the n minus 1 is a subset of n. So that is mean the less than of n. So n minus 1 belongs to theta of n. Okay. So here the general plan to following in analysis of non-recursive algorithm. So general நம்ம என்னென்ன ஃபாலோ பண்ண போறோம் அப்படிங்கிறது நம்ம ஃபைண்ட் அவுட் பண்ணலாம். Okay, right. So first decided and a parameter indicate the input size. Okay. So first we consider the input size because it's very important how many times the for loop will be repeated. Okay, right. Identify the algorithm basic operation. So which algorithm, how to identify the algorithm basic operation? The basic operation must present in the inner for. Okay, so that operation is executed more number of times. That is the basic operation. I already discussed in the previous classes. Check whether the number of times the basic operation is executed depends only on the size of an input. So the basic operation is repeatedly repeated depends upon the input size. It also depends the additional property, the worst case, average case, and the best case. Okay. So it is necessary to find the best case separately. Okay. So compulsory you find out the worst case and the average case. So if it is necessary, you find the best case also. Right. Set up a sum of expressing the number of times the basic operation is executed using standard formula or rules of sum manipulations is occurred in general analysis of non-recursive algorithm. Okay. Right. Frequently use summation formula and rules of sum manipulations. So here is C. So C is a function, A is a function. So summation 2. So sum of I equal to 1 up to U is what is that? C A of I. So C on the outside function of C into summation of I equal to 1 up to U A I. This is rule 1. So rule 2. The summation of I equal to 1 up to U. Here you mentioned that AI plus or minus BI. So you separated. So first summation of I equal to 1 up to U AI plus or minus. Then summation of I equal to 1 up to U BI. So this is summation 2. Okay, summation formula. So up to that the summation of L equal to I equal to 1. Okay, up to N equal to 1 equal to upper limit minus L plus 1. So L equals to U minus 1 time is repeated. So U minus L I L plus 1, where L less than or equal to U are same lower and upper integer limit S1. Okay. Right. The second formula is also summation of I equal to 0 to N I. Then is right to that I equal to 1 summation of N. I equal to 1 plus 2 plus 3 plus up to N. So this is equal to N into N plus 1 by 2. So this is approximately half N square. Half N square. So this is less than or equal to there is a theta of N square. So this is the summation to 2. Okay. Right. So second, next is called the mathematical analysis of recursive algorithm. So previous case we studied the non-recursive algorithm. So here we find out the recursive algorithm. What is the recursive algorithm? The algorithm is called itself is called recursive algorithm. How to apply the general framework for analysis of algorithm to analysis recursive. Okay, example, compute the factorial function. So f of n equal to n factorial. Here n is the arbitrary non-negative integer, so non-negative function. So n value is negative, so it won't work. So even n value is positive. So n factorial is equal to n into n minus 1. So again the n value is multiplied by n minus 1 value. Okay, right. So suppose 5 is n value is 5, so 5 into 4 into 3 into 2 into 1 is called the factorial of 5. Okay, so here n minus 1 factorial n for all n is greater than 1. So here suppose the rare condition n equal to 0. Okay, what is the factorial is? value is 1 by definition. So f of n equal to, so f of n is nothing but a small function to find out the factorial value. So f of n minus 1 into n. So n is a numerical value, f of n minus 1 is a function. That function is recursively called. So algorithm here, n equal to 0 is automatically written 1, else is written f of n minus 1 into n. F of n minus 1 into n. Okay. So n itself is indicating the algorithm input size, m of n, number of times the basic operation is executed. Here the basic operation is nothing but a multiplication. The number of times the multiplication has occurred. So f of n equal to f of n equal to f of n minus 1 into n. So this is a factorial value for all n greater than or equal to 1. Okay. So now we can apply the mathematical functions. So this means the multiplication of n. How many times the multiplication is repeated to execute the given function for given value. So m of n is nothing but the multiplication of n. That is the input size. So here m of n minus 1. Suppose you consider that n equal to 5. So input size is 5. So now your 5 into m of n minus 1, that is will be 4. So 5 into m of n minus 1, that is into 5 into m of 4. So the m of 4 is repeated. Okay. So 1, the n 5 is the multiplication. So here 4, 2, 3, 2, 1. So 5 times the multiplication is occurs. So the value is 5. So functions of n is implicitly express the functions of n minus 1. So it's called the recursive relations or references. Okay. So number of multiplication is occur when n equal to 0. So no multiplication is occur. So we call stop value n equal to 0. So m of 0 equal to 0. So no multiplication is occur. So suppose n value equal to 0. So no recurrence relation will be executed. Technique to solve recurrence relation is called the method of backward substitution. So here m of n equal to m of n minus 1 plus 1. Substitute m of n minus 1 is actually m of n minus 2 plus 1. So you substitute for number, you are getting the value of m of n minus 2, m of n minus 2 plus 2. So again you substituted m of n minus 3 plus 3. So m of n minus 5 plus 5. So this is the general formula is nothing but m of n equal to m of n minus 1 plus I. Okay. So m of n equal to m of n minus 1 plus 1. So m of n minus 1 equal to n of n minus I plus I. So you substitute that n equal to n minus 1 plus n. So you finally getting the value of n. Okay. Finally getting the value of n. Suppose 5 factorial number of multiplications occur in the 5 factorial. So 5 is the input size. So n is 5. So what is the value of 5? Value of n is 5. 5 is the answer of that number of multiplication after the 5 factorial is 5. Okay. Right. General plan for analysis efficiency for recursive algorithm. So first point is same to non-recursive algorithm. So decided on a parameter indicating an input size, identify the algorithm basic operations, number of times the basic operation is executed. So set up a recurrence relation with an appropriate initial condition. Number of times the basic operation is executed. Solve the recurrence relation. At least certain the order of growth of solution. Okay. Right. We find out that the simple example is using a binary search. The binary search is a very memorable efficient algorithm for searching in a sorted array. Okay, in a sorted array, it's not used for an unsorted array because sorted array is already arranged array. You find out the given element is using a binary search. Okay, So the compare search key with the array middle element. So each and every time the binary search, the given element is compared with the middle element of the array. Suppose the middle element of the array is equal to the given value, if we find out the value. Otherwise, we just check that middle element is given key element. So less than that middle element, so key element is less than the middle element. So only we search for first half of the array. Suppose the given element is greater than the middle element, so search the next half of the array. Okay. So it is then repeatedly. So it's called recursively for the first half or second half. Depends upon the given element is less than or greater than of the mid array element. So it is to identify in this example. So a of 0, a of m minus 1, a of n is a mid. So here a of n plus 1 up to a of n minus 1. So if the k value is less than the first half is search, the k value is greater than the second half will be search. So algorithm for the final search. So you pass that a of n, a of 0 to n minus 1 is the array element. So k is the given searching element. Okay. So the given condition is the given array is already sorted. Okay, right? The index of array element, otherwise 1 or not. Suppose the given key is present in the given array, so it's written the index value of array. That is mean the position of the element present. Okay, right? We start from I equal to 0 to r to the n minus 1. R is a level. So while so L less than or I less than or R. So here you find out that the mid L plus R divided by 2, you find out the mid. Okay, that mid value is compared to K is written. Suppose is equal to is written. Otherwise, again you go for the rearranging the lower and the upper value of L and R. Suppose less than means, so the given element is less than or mid of the element at the time R value only change. R, that is mean the real value only change. Real value is nothing but m minus 1. M minus 1. Otherwise, the low value is change. The low value is nothing but m plus 1. So in this manner, the formula is repeated, the function is repeated, you find out the value. So this is called the searching element using a binary search. Thank you. We will meet again.